Hello everyone, this is Nilesh Gule. Welcomes you to the class of LINQ. In the previous class, we talked about .NET collections. And now I'm super excited to tell you about the very interesting feature of .NET that is nothing but language integrated query. But before we move on to the session, you need to understand two important prerequisites. One is var keyword and another is anonymous types. Let me begin with the var keyword. The var keyword enables implicit typing, means when we declare the variable, we need not to write the data type explicitly. Usually, if you know, we declare the variable like this: integer age is equal to 42. And there we are telling the compiler that the age variable is of integer type, and then we are assigning the value. Now, with the var keyword, compiler becomes little more smart. When we assign value 42 to the age, compiler infer the type of age as integer. We are just writing the var over there, but compiler will guess the type depending on the value that we have assigned. This is applicable for the other examples as well. In this example, you will find that the name is inferred as string type because we are assigning the string not only for the built-in type, but this can be applied to the user-defined type. This can also be applied to the generic type and so on. You can see the example below where nums is treated as the list of integer. It is not mandatory that you are only assigning straight away object or the actual value. You might even call some function, and then the return type of that particular function will be considered as a data type of our variable. This is also possible. Let me give you some examples. Let me take you to the Visual Studio, and there we will talk about example. To save our time, I had written some base code, and then on the top of it, we can focus onto the main content for this session. So let us first talk about these basic examples. Like earlier, we were writing string name is equal to something, and then this name was treated as a string variable. But if you use the var keyword, the compiler will automatically treat this name as string variable. You can check it into the IntelliSense. Something similar, we can do it for the age is considered as the integer. Then you can also try this with some boolean value, like we have some flag and we are mentioning it as true. So this is automatically considered as a boolean value. This is also applicable for the floating point or any other values. Not only limited to the predefined type, we can also use it with the user defined type. So here you will find that I have written few classes. These simple classes, let us try to use it over here. I can declare var E1 is equal to new employee. Here E1 is considered as of type EMP, or for that sake I can try var D1 is equal to new department. Again, D1 is treated as the department type. Please understand that we could write it like DPT D2 is equal to new department. But in this particular case, we are explicitly mentioning type. In this example, compiler at compile time is guessing the type, and both of these lines will be generating exactly same IL code. That is the reason whether you are writing like this or you are writing like this, it will not have any impact on runtime performance. Now that you have understood the basic use of this var with built-in type or user-defined type, let me give you another example. We can also try to use it with the generic type. So let me try var list, and I want to create a simple list of integers. We can also assign it to some values, maybe 1, 2, 3, 4. And how do we access this list? How do we print this list? We can print it using the for each loop. So to print it using for each loop, we will use for each integer number in list, because it is a list of integer. However, since we have the var keyword, we have already declared list of var type, it will be much more easy to write var n is in list, and then we can print that particular integer. Let us try to run it and check if it is working well. So this makes your code pretty straightforward, and every time you need not to be aware of exactly the data type, or you need not to write it every time the data type over here. The compiler is doing smart work over here. However, this particular var has got certain limitations. Note that since it is going to consider the data type based on the initialization, the variable must be initialized at the point of declaration. Means you can write var and you are declaring a variable 1, but without assigning any value. What will happen? This will be a compile time error saying that it must be initialized at the point of declaration. It is not allowed directly. So this is error, compiler error to be specific. Not only that, you need to also understand that you cannot assign it to null. Means if I'm trying to make var2 equal to null, again your compiler is confused. How I can decide the type of var2, because the right hand side is null. So this will also cause the compiler error. However, you can do a little smartness over here. Instead of declare var2 like that, we can assign null, but we can do a typecasting. If you are doing typecasting, you are telling compiler that I was intending to assign the string value, and that is the reason compiler is considering var2 is of type string. Then we can also understand another very important concept, where you need to note that once a particular data type is assigned, then compiler has treated var3 as integer. Now it will remain integer. You cannot later on say var3 is equal to some other string. And if you try to say so, this will cause the compiler error. You cannot change the data type later on. Please note that it is static typing. It is compile time typing. It is not dynamic typing. No runtime penalty, but also you cannot change these types at runtime by reassigning to some other variables later. Then you need to also note that this particular feature is limited to only the local variables. You cannot use it for the method arguments. You cannot use that for method return type. You cannot use them for the fields or properties. This is only for the local variables. These are the important concept that you should know about var keyword. The question is where these var keywords are used. The var keyword is primarily used when your right hand side is very much readable. You can guess the type from the right side immediately. It is useful when people go for LINQ projections or people go for anonymous types. But you should avoid using var keyword if the code is not giving the clarity about the data type on right hand side value. At that time, using var can make your code very much unreadable, and you should avoid that. Now that you have understood about the var keyword, let us talk about the anonymous types. The anonymous types are compiler generated, immutable reference types, and they are primarily used for storing the temporary results in the local scope. You can see one quick example over here. Here I have used new, and then instead of giving any type name, directly use curly braces. And inside these curly braces, I'm writing name is equal to something and age is equal to something. In this particular case, this is auto implemented property, name property and age property. And a new data type is created by the compiler. Of course, that data type doesn't have any name, and that is the reason you cannot assign it with some variable to which we can give the type directly. But yes, this is where we can use the var keyword effectively. Now, let us go ahead and try to write some examples of this anonymous type and understand few more things about anonymous. Let me name this as main1 and we will go for main2. Inside this, we will talk about these anonymous types. Let us first declare the same example. So P1 is equal to new. I'm writing some name is equal to something, age is equal to something, and city is equal to something. This is how the anonymous type is declared. As I was saying that this P1 is var. Its type is not named. You can see in IntelliSense that it is considered as something string name, integer age, and string city. If you at all want to see the type name, we can use the getType method of the object class. So let me try to find out what is the type considered by the compiler over here. I can use p1 dot getType and let us try to print that. Let me run this. Here you see that the type is anonymous type, where the first property is string, second one is int32, and third one is again string. If you open ILDism, you can actually see this type created into that IL code. Anyway, we can go ahead and then we can access these properties individually. To access each property individually, you can mention name is equal to p1.name. You can access, let's say, age. In a similar way, I can write age is equal to p1.age, and on the similar line, I can also print the city. Let me run this and you see the output. So accessing these values is very easy because basically it is auto implemented properties which we earlier discussed in the properties class. However, you need to note that these anonymous types are designed to hold the temporary data. This is popularly useful for projection. This is not designed for data manipulation, and that is the reason by default all these properties are read-only properties. You cannot try to modify them later. So if you try to make age is equal to something later on, this will give you the error saying that this particular property is a read-only property. You cannot modify this. So this is compiler error. I hope you understood the basic idea of the anonymous type. We can go ahead and we can understand few more things about anonymous type. Anonymous type will have some auto implemented methods. Like you will see that by default toString method is written. By default equals and get hash code method is automatically generated. Being a programmer, I cannot write a single method inside the anonymous type. But these basic methods are given to us by compiler. We can try to use that. Let's say I want to print the P1 and I can directly call P1.toString. Though I have not implemented toString, you can see that it is generating some output. It is very much readable way that it is representing my object state. Going ahead, not only toString method, but it also generates equals and hash code. So let me give you example. Let me have another object, let's say P2. And can I check if this P1 and P2 are equal? We can try it using the equals method. And if P1 and P2 are equal, let me display the message that P1 and P2 are equal. Otherwise, I can put the message that they are not equal. Here you will see that it is having exactly same values for all the properties, and that is the reason it is equal. However, if there is change in any of the property, then the output will be not equal. It means that the equals method by default compare all the properties. Same thing is true about hash code. The hash code is also calculated on the basis of all available properties. Now you understood the auto-implemented properties of this anonymous type. Then let us talk about, can we create the array of it? Let us give a try. Let's say I want to create the array of persons. I see that persons1 is equal to create array, I can directly use the array sign after new, and then we can start creating the anonymous objects over here. We can mention name is equal to something, age is equal to something. Similarly, we can create few more objects. So here person1 is the array of these anonymous objects. We can access it using for each loop. So let us try it. For each where p in person, I can print this. As you know that toString method is by default available. So if I run this, you will be able to see the array is available. I hope you know the basics of array. The basics of array says that all the objects must be of exactly same type. So if you have any additional property over here, what will happen? If you have any additional property, this object is having a different anonymous type, and this object is having a different anonymous type. You cannot create array out of this. So all properties must be exactly same in name as well as data type if you want to create the array of anonymous type. Well, then can we also create the list of it? Answer is no, because you cannot really write list of anonymous type. This is not allowed, and that is the reason creating a list directly is not permissible. But what we can do is we can create the list from the array. Means we can have the array, and whatever array we have created, we can apply, let's say, toList method, which will convert that array into the list, and then we can iterate it separately. Let me try it. Let me put one console.write line as a empty line over here so that you can differentiate the output. So let me run this and you will see that this is where we have printed the list. I was telling you how you can use anonymous type for creating arrays. You can create the list. This is about the basic fundamentals about var and anonymous type. I just want to reiterate that both of these features are implemented at compile time. So the IL code is generated by the C# compiler, and that is the reason at runtime there is no performance penalty. There is no memory overhead too. So you can use these features effectively into LINQ. Now you are ready to learn about LINQ. So what is LINQ? LINQ is SQL-like syntax in .NET languages. .NET, C# and VB.NET has got full-fledged support of LINQ. The other languages may have limited support. This LINQ brings you the SQL-like syntax for the .NET collections, databases, XML, in-memory object, and so on. So you can use LINQ directly for data processing. It provides you the declarative syntax. Declarative syntax means you have to just tell what to do, not how to do. It will internally execute it effectively and efficiently. Second thing, LINQ is type safe, meaning by the data types are known at the compile time. And since they are known at the compile time, there is no execution penalty at runtime for type checking. Of course, the actual LINQ execution is going to execute at runtime only. Another interesting feature is full IDE support. If you want to compare LINQ with Java, there is a concept called as a JPQL. However, typically we write JPQL into the strings. That is the reason compiler is not able to check it. They are parsed at runtime by the JPA frameworks. However, LINQ is very much integrated into the language syntax and you get full-fledged IDE support with IntelliSense for LINQ. This reduces the chances of syntactical mistake. Then, as I said, it is a unified model. You can use same syntax for collections also, databases also, XML also. LINQ comes in two different flavors. One is method syntax and another is query syntax. We will discuss both the syntax one after another over here. And then at the end, I will tell you about the lazy evaluation of the LINQ. So let us first talk about how we can use the method syntax. Let me first tell you these methods of LINQ. They are extension methods for the IEnumerable. So any .NET object which is inherited from IEnumerable, these methods will be available. Example methods given over here like where, first or default, select, order by, sum, group by, and many more methods available. Let us go to the Visual Studio and see some examples of method syntax. So let me take you to the Visual Studio and then we can talk about the LINQ syntax. Here I have already created some classes for you like employee class with around 8 properties, and then I also have the department with 3 properties. Now I have already created some collections over here. It is list of employees where you will see that it is a list of 14 employees and we have list of 4 departments. Using them, we will look at the syntaxes one by one. Let us start with very basic, very simple level example. By default, we have the whole employee list. But what if I want to get only the names of employees? Is it possible? Answer is yes. You can start with the var result, and then I can mention that employees dot select. And while selecting, for each employee, I want to select the employee's name. That's it. Please note that employee name is a string. So this will basically fetch IEnumerable of string. That is the reason result 1 is IEnumerable of string. If you want to print it, we can use for each loop. So for each variable name in result 1, I can display it. Let us name this method as main, and then we can run this. We get only the names. Let us continue further. We want to talk about the employee names and salaries. Fetching only name was very easy because we were having the string as a built-in type. However, now we do not have any built-in class which is going to collect the name and salary, string and double. This is exactly where anonymous types will be very helpful. Let us see how we can do that. I'm writing var result2 is equal to employees dot select, and then for each employee I want to create a new object, and this new object I want to fetch, let's say, name and salary. So you can write name is equal to e dot ename, and let's say sal is equal to e dot salary. This is how we can fetch the data, and then we can print it over here. Let me print each item one by one in console.writeLine. I will also add one more empty line over here. Let me run this and you will see the output. Please note that over here the property names are name and sal, which we have given explicitly. If you want this property name to be taken automatically, that is possible with anonymous types. How we can do that? Let me copy this and rewrite it with a little change in a syntax. Instead of writing name is equal to, let me just mention e dot ename and e dot salary. Here, automatically the anonymous type property names will be considered as ename and salary. That is nothing but the existing properties. Let us run this and you can cross check that. The properties are ename and salary. Then we can go ahead and we can do some filtering. Let's say I want to find out the employees with salary greater than 1000. How we can do that? Let me start with var result3 is equal to, I can write it employees dot where, and then we want to put condition on salary. So I can say that for given employee, I want to give the condition like e dot salary greater than 1000. This is my condition. Please note that in this method, in where method, we have the delegate, function delegate, and typically we expect that it will return a boolean value. If the condition is true, the record is filtered. If the condition is false, then the record is not taken. We can start for each loop once again and try to print each item. Let me again add one empty line there. You run this and you will find only the employees with salary more than 1000. The employees with salary less than 1000, they are filtered out. Let us continue further. Now, I want to talk about sorting. I want to sort the employees by employee ID, and there is ready-made method OrderBy. How we can do that? So where result 4 is equal to employees dot order by. Again, in this case, we are having function delegate and we need to return the value on which sorting is to be done. Here, since we want to do the sorting on employee ID, let me return employee ID and then we can print this item and again we'll put one empty line. Let us run this and you check that all the employees are now in the sorted order from lowest to highest. Let us continue further. What if I want to do multi-level sorting? Means I want to first sort by department ID and then I want to sort by salary. Is it possible? Answer is yes. And for that, we will do it in two steps. Let me write it. Result 5 is equal to employees. The first level, I want to do order by where I'm saying that E and I want to sort by department ID. This will provide me sorting by department ID. But on the top of it, I want to also sort by the salary. That can be done by cascading the method again, then by descending or then by regular for ascending sort where I can mention e dot salary and then we can try to print the result. Let me run this and you will see that I will get all employees with department number 10 first, then 20 and then 30. And in each department, the employees are sorted in the descending order of the salary. For department 20, also the employees are sorted in the descending order and so on. So you can do multi-level sorting. If you want to sort by one more parameter, again you can continue and you can again use either then by or then by descending as per your requirement. Now we have more interesting feature. We seen basic filtering, we talked about the basic sorting, we talked about the basic projection where we selected the elements. But now I want to perform the summary operation. Let's say I want to find out the job wise total salary or department wise average salary. How this can be implemented? For that, the grouping feature is also available in LINQ. How we can do that? Let me explain this in two steps. Here we have group by and again it is taking one delegate which is expecting you the employee as an input and then you should return on which you want to perform the grouping. Here I want to perform grouping on the job. Now you understand what exactly is present in each group. So let me use for each variable item in result 6. Please note that over here each item is a group and let me try to print that group directly to understand what exactly it is bringing to me. Here you will see that it is showing me that it is having all grouping objects and this grouping object is having two things. One may be job string and second one is actual employee. Now let me show you over here. We can try to print that job separately as a group key and then I want to print corresponding employee. How we can print the corresponding employee or other details? Let us try to get that other details by using a nested loop. So let me have a nested loop where we can look for the actual elements in that particular group. So I can again say that for each variable, let's say employee in for this particular group, whatever elements are there, whatever values are there that I want to access one by one and then I want to print it. Let us try to run this and there you will see that I'm getting the jobs individually and in each job we have corresponding employees. For each job, we have corresponding employees. I hope you are getting clarity on this. Now we can use it more effectively for performing the group-wise summarization. See the next example where I want to calculate job-wise total salary. We will do it in a similar way where result 7 is equal to, let's say, employees dot group by, and we want to first group on the basis of job. After doing the grouping on job, I want to get the job name, I want to get the total salary, and I want to get the maximum salary as well. For that, I will use the select, and in select I am getting each group. From the group, I want to get three things. The first thing, I want to get the job, which is nothing but the group's key that we printed even above. Next thing I want to get is a total salary. How I can get the total salary? For that, I can use this group dot sum, and in that group, whatever employees we had, then I will get the salary of them. Please note that each group have multiple employees which we printed in above for each loop. Over here, we are getting each employee in that group and then getting salary, giving it to sum so that we get the total salary for that particular group. And then on similar line, we can also find out the maximum, minimum, average or count as per our requirement. Let us try to display this result. I can try to display each item in the result 7 and then one empty line. Run this, and now you should see that I'm having job is equal to this, total salary is equal to this, and maximum salary is equal to this. Likewise, we did it for all 5 unique jobs available in the employees collection. This is interesting feature, as you can go ahead and you can even implement more complicated features like joins and other things. But I'll show you some examples next. Let us talk about the employee method syntax. Here I have more complicated requirement. Then it is saying that I want employees with salary 1000 and also sorted by name. It means I'm looking for combination of where clause as well as order by. Let us try it how we can implement it using the LINQ method syntax. We can try this like where we will have result 8 is equal to. Let us do it step by step. First, we will use where clause and we will apply the condition like salary is greater than 1000. But then we want how we can sort it by employee name. For that, whatever is the output of this where clause, we will continue further and we will use order by and then order by name. Let us try to print the result. So for each, I'm getting this. Let me run this and you will see that here we have only the employees with salary more than 1000 and they are sorted by the name like Adams as a first, Ward as a last. Then the same thing can be very well implemented using the LINQ query syntax. So this query syntax is a bit different. Let us take a look at how you can see that. This syntax, you use it with from keyword. So typically we start where result 9 is equal to, I can use the from each employee in my collection. And then we can directly select all the employees. However, we do not want to select all the employees in the collection. Rather, we want to apply the condition. The condition is where E dot salary is greater than 1000. Now I'm getting the employees whose salary is greater than 1000. But I also want sorting. This sorting can be done by order by, and by default this sorting is ascending order. We can cross check whether we are getting the same result once again. Let me run this and you will find that this will also give you exactly same result once again. However, first time it was done using method syntax. Second time it was done by LINQ query syntax. Let me tell you, when I'm writing a LINQ query syntax, the C# compiler will internally convert it into the same IL code as of this method syntax. So performance point of view, whether you use method syntax or query syntax doesn't affect. However, if you come from the SQL background, then this query syntax is very much intuitive. Let us go ahead and learn this query syntax step by step in detail. So here we will see some simple examples. What if I want to get all the employees? To get all the employees, I will write result and I simply say from IEnEmployees and select all the employees. You can use the for each loop to display it. So here all employees will be displayed at once and with their default order. We have not done any filtering. We have not done any sorting. Let us continue further. Let's say I want to get only the name and salary. So it is about projection. Yes. And this projection can be done by using the anonymous types. How we can do that? Instead of selecting employee, you can use the new keyword over here. And then inside new keyword, you can create anonymous type with required field, ename and salary. Now it will print only these two fields. One is ename and second one is salary. I hope you noted that how effectively we are using anonymous types even in LINQ query syntax. Let us continue further. I want to do only sorting. To do only sorting, let me declare var result 12 is equal to from IEnEmployees. I'm saying order by salary. But if you want it descending, then I should use the keyword descending. If I have not written any keyword, by default it is ascending. And then I want to select the whole employee. Again, I can try for each loop for printing the result. Let us check whether employees are sorted in descending order of the salary. Here you see that 5000 is maximum salary and 800 is minimum salary. Let us go ahead. And this time I want to talk about the summarization. Earlier we talked about the group syntax. Let us see how we can do the grouping over here. So I have var result 13 is equal to from IEnEmployees, and then I want to group the elements. So we can say that group all these employees by department ID. So E dot department ID. Please note that here we need to give name to each group, and that group alias I'm giving it as a G, or you can give any other name as per your choice. After that, now we can select, I want to display the department wise total salary, means I want to display the department ID and then the total salary. So we can create the anonymous type where we get the department ID, which was the key of each group, and then I want total salary. That total salary we can again calculate with the similar logic as of method syntax. We can say group.sum and then we can print the result. Here I should see that there are 3 unique departments. So for each department, the total salary is printed. Like department 20, it is 10,000. Department 30, it is 9,400. Department 10, it is 8,750. So far, we talked about the common syntaxes of LINQ query, but the next one is very interesting, where I have a data from the employee as well as department collection. I have written the employee names in an employee collection, while department name is present in the department collection. Can I get the data combining these two collections? In SQL, probably it is very easy writing join. Let us see how it can be done in a LINQ. So we have var result 14 from E in employees. I need to join it with each department object. And this join, I need to tell it on which column they should be mapped. So I'm saying that it should be mapped on employee dot department ID equal to department dot department ID. However, one important thing to be noted over here, we should not use equal to or not equal to kind of sign. Instead of that, if you want to do this equality check, you must use the equals keyword in LINQ query syntax. You need to mark this difference. And then we can select the employee name and we can also select the corresponding department name. That becomes very easy job. Then we can write for each and we can try to print them. Now you'll see that we have 14 employees and they are present in 3 departments. So you can actually see that this Smith employee is in research department, Alan is in sales department, Jones is in research department, and so on and so forth. I hope this is very intuitive syntax used in LINQ and you can very easily combine two collections. Now that you've seen the power of LINQ query syntax, you need to also understand that at times we need to do combination. We need to do like query syntax as well as method syntax, some hybrid work. See this example where I want top 3 employee, skipping the first employee. How we can get that? Let us do this kind of top based on salary. So we already can do sorting on basis of the salary. Let us first try that. Let's say where we have result and then we are trying to do the sorting. Let's say from E in employees, I want to order by E dot salary in descending order and we can select the employees. But now there is a problem. You cannot have a limit kind of syntax. If you have some background of MySQL or other query languages, they have built-in syntax for limiting the rows. Unfortunately, this feature is not present in LINQ. So how exactly I can implement that? So we can do the combination of the query syntax and whatever is the output of the query syntax, we can continue using the method syntax. Like we can skip the first record. We have the method available for skipping the record and we also have method available for taking number of records that you want. This is the hybrid syntax. We can check which are top 3 employees. The topmost was King with the 5,000 salary, but we are skipping him and then we have the next 3. And you can check that the next 3 are the employees with the salary 3,000 and 2,975, Scott, Ford and Jones, right? So at times you might need to do the combination of query syntax and method syntax both. I hope this should have given you fair idea about the LINQ query syntaxes. Now I want to tell you few more things about LINQ. Bit advanced stuff to know about. This LINQ is not limited to only the method syntax and query syntax, but there is something called as a set operations. So let me again do the set operations on the same data set like employees and department, where I want to find out the unique employee jobs. Let me tell you, these typical set methods are available on IEnumerable. So though I'm showing you in the LINQ class, you can use it in any other collection as well. Let us see how we can do it over here. Let's say we want unique employee jobs. So we can continue. Let's say result 1 is equal to, I want to get the employees job. So let me use employees dot select first, where we are getting all the jobs, and then it is returning me IEnumerable of string. On that I can apply distinct, which is giving me the unique jobs over here. I can use for each loop and I can display it. Let me print one empty line over here. Let me run this and check whether I'm getting the unique jobs. We have total 5 jobs over here. So when I run over here, it should give me 5 unique jobs. Now, similarly, we can also do union of employees in department 20 and all clerk. Now, to do these operations, let me first create 2 collections. How we can do that? Let's say where I want to make employees in department number 20, and that can be done by using employees dot where, and we can put the condition department ID is equal to 20. Then I want to also find out all the jobs. Let me have another collection called as a clerks, which is job is equal to clerk, and then we can do the union of both of them. That can be done very easily by saying employees 20 dot union, and we can pass the clerks. This will return me my next result, and I can write it where result 2 is equal to this. We can print this combination over here. Let us check. Please note department 20 has got total 5 employees, and there are additional clerk in department number 10 and 30. You can check that. So we have employees with department number 20 and 2 clerk, one from department 30 and another from department number 10. Now, instead of union, I can also take the intersection. For intersection, you will note that department 20 also have 2 clerk, one clerk over here and another over here. And then in a clerk collection is also having total 4 clerk. So if I take the intersection, basically I will only get the clerks in department 20. Let us check that. That can be implemented very easily. Already I have created a collection, so I will simply copy paste the basic logic, and instead of union, let me call it as a intersect. Now we will print the result, and as I said, this will give me only the clerks in department number 20. Do you see that? We have Smith and Adams, clerk in department number 20. The next operation is except, where we are subtracting second set from the first set. It means that we are removing the elements from the first set which appears in the second set. In other words, I want to display all employees in department number 20 other than clerks. How we can implement it? As I said, there is a ready-made except method. So we can try this. Let's say result 4, and we can use except over here. That's it. Let us see which employees are there in department 20 other than clerk. You'll see that there are 2 analysts and 1 manager. Please note that these set operations possibly we already discussed into the collections class, where we talked about the hash set and the operations on that. Let us talk about the next advanced feature, like nested queries. You can also write a query inside query. Let's say I want to get the department name along with list of all employee names in that department. How we can implement that? So let me give a try. Let's say where I'm writing result 5 is equal to, I need to get started with the department first, and then for each department I want to select two things. Let's say one, department name. Department name is equal to d.dname. And second thing I want is employee names. So these employee names I can find out by writing another query inside this. This query we will apply on employees. So from E in employees, where E dot department ID is equal to the current department ID, D dot department ID. And I want to get only the name. I can get only the name by saying E dot ename. That's it. Nothing else I need to do over here. Please note that I have not used equals keyword over here. I have directly used equal sign. That equals keyword is used mainly for joins, not for every LINQ query, right? And then we can display this result over here. I want to display the department name, and then I want to also display the employees. Displaying department name is straightforward, and to display all the employees, I can again use for each loop, and I can display all the employee names over here. So let me check if I can get the result. Let me run this, and you should see that accounting department has got 3 employees, research has got 5, and sales department has got 6. Unfortunately, operations department doesn't have any employee. Well, you can also take a shortcut. If you want to iterate through all these strings in any IEnumerable, we have a ready-made method called as string.join. And string.join, you can tell that separator is comma, and I want to pass the IEnumerable, which is nothing but in our case item dot emp names. That's it. This particular string I can display just beside this department name. So let me go ahead and try to display over here. This will give me the output in probably more readable way. You can check that we have accounting with these 3 employees, research with 5, sales with 6, and operations with no employees. I hope you find this is very interesting. This particular feature possibly have reminded you about the subquery concept in the SQL. Now it's time to talk about some advanced stuff and understanding how exactly the LINQ works. In this example, here I have written one very simple query. However, in this particular query, though I am selecting employees with department number 10 and getting only the name of employee, instead of writing a very short lambda, purposefully I try to modify some variable which is outside that lambda scope. This kind of work is usually referred as side effect, because the result of this lambda is either dependent on some external variables or it is modifying some external variable. In this case, we are modifying the external variable. It is considered as the lambdas with side effect. Now you need to note over here that whatever code we have written over here is not actually executed. The actual execution will happen only when this result is enumerated. Means you can see that if I print the employee count over here, right now you will see that this count is 0 because not a single time the count plus plus is executed. Though my department 10 has 3 employees, currently this select part is not executed, neither where part is executed. This execution will be triggered when you enumerate this result. When you use the for each loop, let's say, for example, I can use a for each loop over here for printing these employees. So when I print these employees, at that time, the result is enumerated and you can print the employee count once again. Check the employee count now. Now you'll find that this employee count is 3 because the condition was true for 3 times, and that is the reason it has fetched 3 employees, displayed them, but count is incremented 3 times. Now something that you should really worry about. In this particular case, please note that what will happen if you enumerate the same list twice, directly or indirectly. With the for each, you can enumerate the list. But do you know that you can also use the function like toList or toArray or count or first? There are so many different methods. If at all I use result dot toList, what will happen? Behind the scene, it will enumerate that IEnumerable once again. And that is the reason the count will be now incremented from 3 to 6. You can check that. Let's say we have this is test list and I'm more interested in the count, where you should see that now it will actually show me the count equal to 6. I hope you noted that. So if you have written some code over here which is not intended to be modified or to be executed again and again, at that time you may expect unexpected behavior, undesired behavior. And that is the reason, if you at all want to enumerate this particular LINQ result multiple times, you should not deal with this. Instead of that, to avoid it, it is suggested that whatever result that you have, you can directly convert it into the final list, like where, let's say, result list. And then this result list, you can use it for multiple times. So you can use result list maybe to get the count that you want. You can use this particular result list for doing any additional operation or enumerate on multiple times. That can be very well done. So you can enumerate this list multiple times, but do not enumerate the original LINQ result multiple times. Otherwise, it will be executing each time and give you unexpected behavior. Right now, you should see the list employee count to be 3. Right? Now, I hope you understood all these things about LINQ syntax. And something earlier I told you that whenever we talk about the LINQ, then this LINQ methods are basically extension methods of IEnumerable. Means any class inherited from IEnumerable, you can use LINQ on this. I feel that it is worth knowing it with example. In earlier class, we already implemented a stack and we make that stack as IEnumerable. Let us try to check, can I use LINQ on this stack? For that, let me go ahead and rename this to main4, and I will rename this main to main. Here I have already created a simple stack, and you will see that I have the stack element 11 to 66. I want to display the even number using LINQ query syntax. Can it be done? Since stack is inherited from IEnumerable, technically this should be allowed. Well, how we can do that? Let us give a try. Let's say where I want even numbers, and I can try to write from n in s. I want only the even numbers, so I can use a condition n mod by 2 equal to 0, and I want to select all these numbers. So select n. We can try to print the result over here. Let's say console.writeLine, and I'm printing the even numbers. Let me put one console.writeLine over here, and we will say that it is even numbers from stack. Let me run this, and you'll see that in this list we have three even numbers: 22, 44, and 66. I hope this gives you clarity that you can use the LINQ with any class inherited from IEnumerable. It can be built-in class or it can be user-defined class. Before I end up my discussion on LINQ, there's one small point I want to talk about. It is related to something called as a IQueryable. Just now, I told you about IEnumerable, and I told you that all our LINQ methods are basically the extension methods on this IEnumerable, and that is the reason we are able to perform all these operations one by one. However, this IEnumerable, we are primarily talking about collections, user-defined or predefined collections. And these collections are typically present in memory. When they are present in memory, we are doing operation using IEnumerable, LINQ making my code more readable. That is absolutely okay. However, I said that we can also use LINQ for database execution. If we are using LINQ for database execution, then where exactly my data is processed? Where exactly this where clause will execute? Will it be executed on the client machine or should it be executed on the server side? Please note, we can have the huge amount of data and fetching all the data to the client and then doing processing on the data can be very heavy. It will have memory overheads, network overheads, and also the CPU overhead. This is the reason we have this IQueryable. The IQueryable ensures that whatever LINQ operations we have, they are going to be executed on server side. So whatever operations we are trying, like where operations or like order by operations and other operations, these operations will be sent from client to the server. They will be executed on server. The result will be generated and that generated result will be sent to the client. Due to this, there is no heavy data flowing from server to client and no heavy operations performed on the client. That everything will be handled by the database. We are not really planning for this demo right now. We can discuss about this when we talk about the ADO.NET Entity Framework. I guess so far we talked about so many details about the LINQ. We talked about its method syntax, we talked about its query syntax, and it's time to understand that though LINQ is very intuitive, it is very commonly used for the simple business logic. It is used for filtering. It is used for order by. It should not be used for too complicated logic, especially if it is having deep nested queries or it is having the query side effects. Otherwise, LINQ is one of the very useful feature and very heavily used for the collections as well as databases and other contexts. I hope you found this session very helpful. Thank you very much for listening so patiently. Bye bye.